So Unit 1, Lesson 1 and 2, a grade 9 review on solving linear systems by graphing using technology. So here's our warm-up. Can we determine which one of these 4 points, A, B, C, and D, are on the line y equals 3x minus 7? And we're going to use a tool called Desmos to help us determine this. So I'm going to show you this website. It's www.desmos.com/calculator, and you can use this at home as well. It's a free graphing tool that will allow you to see any kind of graph of any equation that you type in. It's very easy and intuitive. You just simply look at the interface on the left side. The empty boxes indicate where you can type in your equation. So here I'm going to type in y equals 3x minus 7. And then it will show you the equation or the graph of that line on your grid. And we're going to see which one of those 4 points is on this line. Now, one way to do it is to visually inspect. So we could see here at 5 and 8, which is point A. 5 and 8, it looks like, is on the line. If I wanted to be absolutely sure, I can convert my equation into a table of values. So I can convert it to a table. And I can plot the x value 5, and it will tell me what the corresponding y value is. It's 5 and 8. So that is on the line. What about point B? Well, point B is negative 2 and 1. Well, if I look at the x value at negative 2, the y value is not negative 1, it's negative 13. So it's all the way down here. So it's not where we expected. So B is not a point on the line. So A is a point on the line. So A is right up here, but B is not. What about C? So C says 1 comma negative 4. Sorry, 1 comma positive 4. Well, as you can clearly see, at x equals 1, the y value is a negative 4, not a positive 4. Okay, so C is not a point on the line. And D is negative 6 and negative 25. Well, I don't see negatives, but negative 6 is here, and negative 25 is further down in the graph. I could zoom out and scroll down a little bit, or I could just type in negative 6 into my table of values for the x value, and it will tell me that negative 25 is the y value. So I can conclude that points A and point D are 2 points that are on the line y equals 3x minus 7. B and C are not. Okay, so let's look at solving a linear system. Now, this was done in grade 9 using a graph. I'm going to show you again how we can solve this linear system using Desmos. So first of all, let's remind ourselves, what is a linear system? Well, a linear system is 2 or more lines. Okay, to solve a linear system means to find the point that exists on both lines. And we call this point the point of intersection. Or we can also call it the solution to the linear system. And we express this point as a point x comma y. Okay, so if I look onto Desmos now, let's go back to Desmos. I'm going to erase my first line here. Let's make a blank graph. And I'm going to type in the first equation. So we have x minus y equals negative 1. And so it's going to plot that line. And I'm going to click on the space below it to enter my other line. So 2x minus y equals 2. So there's another line. And you'll see that both lines cross each other at this point right here, 3 comma 4. So at x equals 3, the y value is 4, and that point right there is the solution, or the point of intersection of both lines. So here I'm going to write 3 comma 4 as my solution. So let's look at solving some problems, going through some examples, and how we can solve a linear system graphically. Okay, so we're going to use Desmos to help us do this, as we're using technology to help us with this section. So example 1, determine a pair of numbers that have a sum of 10 and a product of negative 24. So if we're going to deal with a pair of numbers, I might need to define some variables. So why don't I define x and y to be those two numbers. So I know that if I have x and y, their sum is going to be 10. So x plus y equals 10. And the product of those two numbers is negative 24. So x times y. Now if I write x and y right beside each other, that means they are being multiplied together. So this means they are multiplied. Okay, and so x times y is equal to negative 24. Okay, so what two numbers, x and y, will give me those two possibilities? So I need to write, here are two equations, and I need to put these two equations into Desmos. Let's go back to Desmos. Here we go. Let's erase those two old lines, put the new ones in there. X plus y equals 10. Here's my first line. And then we have x times y equals negative 24. Okay, so it turns out we don't have another line there. We actually have a different shape. But we can see where both graphs cross each other. So this graph right here crosses at 12 and negative 2. And this graph right here crosses also at negative 2 and 12. So these are the two solutions. Now you can have more than one solution. That's possible too. Okay. Okay, and this can happen especially when you don't have just two lines, but a line and something else. Okay, so negative 2 and 12, and the point 12 and negative 2 are solutions. Okay, so therefore, the pair of numbers are, or is, 12 and negative 2. Okay, let's look at another example. Example 2. You are on the prom planning committee and are comparing the cost of places to hold the dinner and dance. Burlington Convention Center charges $5,000 and $75 per person. Holiday Inn Burlington charges $7,500 plus $50 per person. You need to figure out for what number of people the two options are the same cost to help you decide which one to book. So here we are looking for the point of intersection. So let's define two variables here. X is going to be the number of people, and y is going to be the cost in dollars. Now you may remember how to create an equation from grade 9. When you look at these values, one is going to be the initial value, or the starting value, and the other is our rate. Okay, our unit rate, $50 per person is a rate. So we're going to create an equation by using that fact. So for the Burlington Convention Center, the equation will be that the cost to y is equal to $75 per person, so 75 times x, the number of people, plus our initial value of $5,000, okay, or initial fee. And we also have the Holiday Inn cost as well. So Holiday Inn Burlington has an equation where the cost y is equal to $50 per person, so 50 times x, which is the number of people, plus the initial fee of $7,500. So here are the two equations that we are going to use to plot on Desmos and find their point of intersection. And this time you will have two lines. So let's go to Desmos, let's clear our grid, and let's plot our two equations. So y equals 75x plus 5,000. And here we have y equals 50x plus 7,500. Now our grid scale won't show the graphs unless we zoom out. So we're going to zoom out, both in the x and y until we get into the thousands. Here we go, and now you can start to see our graph. All right, and we can see a point there where the two lines intersect. And if I click it good enough there, and if I want to zoom in just to make sure I clicked on the proper point, you can see Desmos will tell you what that point of intersection is. And here it is, 112,500. So that is my solution. The number of people is x, which is 100, and the total cost is $12,500, the y value. So let's write that down. So the solution to this equation, or you can say the point of intersection, is 112,500. And so therefore, my concluding statement, both locations cost $12,500 if 100 people attend. Okay, let's look at another example. So example 3, you play hockey and you get 2 points for a win and 1 point for a tie. Last season, your team had a total of 90 points. You had 4 times more wins than ties. How many games did you win? So again, we need to create 2 variables that we can use to model this situation. So we're going to say here x is the number of wins and y is the number of ties. Okay, why wins and ties? Because we're told, well, wins and ties are the information we're given in our problem. Okay, so let's look at what equations we have. So 2 points for a win and 1 point for a tie. So last season, your team had a total of 90 points. So let's create an equation for our team. So our team will have a certain number of wins, and for each win, we'll have 2 points. So 2 times the number of wins, which is x, plus the number of ties, it gets you 1 point for a tie, so plus 1y, 1 times the number of ties, gives us a total of 90 points. Obviously, losing a game doesn't give you any points, so there's no variable for losing because there's no points for losing. Okay, all right, so we're also told that our team has 4 times more wins than ties. So we can use this sentence to create another statement or another equation that says the number of wins, x, is equal to 4 times the number of ties, so 4 times y. Okay, so we multiply the number of ties by 4 to get the number of wins. Okay, so we're going to plot these 2 equations to determine the solution. Let's go back to Desmos. Let's erase our original 2 graphs. Click on the home button to bring us back to our default zoom. And here we go, 2x plus y equals 90. And the other equation is going to be x equals 4y. And I can't see the other equation, the first one we wrote, so I'm going to have to zoom out a little bit. So, yeah. And there we go. So now we can see where the 2 lines, they intersect here at 40. So at the x value of 40, the y value is 10, and there is our solution. So let's write that down. Solution is 40, 10. So what does this mean? Well, x is the number of wins. So therefore, our team won, or you won, 40 games, and tied how many games? Well, we tied the y value number of games, so tied 10 games. Okay, let's look at example number 4. The Tragically Hip, which is the name of a band, held their last concert in Kingston, and 15,000 people attended. Kingston is the name of a city in Ontario. The tickets cost $85 for students/seniors and $125 for adults. The concert took in $1,625,000 in total. How many adults came to the concert? So again, we need some variables here. If we are using students and seniors and adults, we can use x and y to represent those 2 items. So let's say X is the number of student / senior tickets sold. And we're going to let Y be the number of adult tickets sold. Okay, and so let's create our equations based on the information given. So we have two kinds of equations to make. One for the number of people attending the concert, and the other equation will come from the total amount of money made from selling tickets. So let's focus on the amount of money being made selling tickets. So we have $85 for each student senior ticket. So we have $85 multiplied by the number of students and seniors, so 85 times X, plus we're going to add the amount made from $125 tickets for the adults. So $125 times the number of adults, which is represented by Y, is going to equal the total amount of money that the concert took in, and they took in $1,625,000. So that's our first equation based on the money taken in. The second equation will come from the number of people attended. So we're told 15,000 people attended, and that's composed of the number of students and seniors, X, plus the number of adults, which is Y, and that's going to equal 15,000. So here are the two equations. Their intersection will give us the solution to this problem. So let's go to Desmos. And once more, we are going to type in our equations. 85x plus 125y equals 1,625,000. And the second equation is x plus y equals 15,000. And I can't see the graph, so I'm going to have to start zooming out rather, until I see my two lines, because these are fairly large numbers. And there they are. And if I look carefully at where the 2 points intersect, it tells us here that 6,250 and 8,750 is the solution to this linear system. So let's write that down. The solution is 6,250 for X and 8,750 for Y. And so therefore, if X is the number of student senior tickets sold, we can say therefore they sold 6,250 student / senior tickets and the Y value is the number of adult tickets, so 8,750 adult tickets. Okay, and that ends this lesson and my examples. You have some practice problems you can attempt to do down below. Use Desmos to help you graph the equations that you generate from these questions, and use Desmos to determine the points of intersection. Okay, that's great. And that ends this video.